Section 8.2, Polygons. A polygon is a closed figure in a plane determined by three or more straight line segments. The straight line segments that form the polygon are called the sides, and a point where the two sides meet is called a vertex, plural vertices. We met that term in the last section. The union of the sides of a polygon and its interior is called the polygonal region. A regular polygon is one whose sides are all the same length and whose interior angles all have the same measure. Polygons are named according to the number of sides, and we see here in this chart, a lot of these names are going to be familiar to you. 3 sides is a triangle, 4 sides is called a quadrilateral, 5 sides pentagon, and so forth. Now, the sum of the measures of the interior angles in a polygon is given by this formula, n minus 2 times 180. And so we see for a triangle, n would be equal to 3. 3 minus 2 is 1. And so the sum of the measures of the interior angles in a triangle is 180 degrees. Likewise, for a quadrilateral, 360, and so forth. But you want to remember that formula, n minus 2, where n is the number of sides, times 180 gives you the sum of the measures of the interior angles of that polygon. Determine the sum of the measures of the interior angles in an octagon. An octagon has 8 sides, and remember the sum of the measures of the interior angles is n minus 2 times 180. So we had said that n is 8 here, so 8 minus 2 is 6. 6 times 180 gives us 1,080 degrees. Now we also want to know that if this is a regular octagon, what's the measure of each angle? So if it's a regular octagon, there's 8 sides and 8 angles, and each of those angles is going to have the same measurement, which is 180 divided by 8, or 135 degrees. Types of triangles. We have an acute triangle, we have an obtuse triangle. In an acute triangle, all the angles are acute. In an obtuse triangle, one angle is obtuse. In a right triangle, we have a single right angle. In an isosceles, now we're going to deal with the side, the lengths of the sides. We have 2 equal sides in an isosceles and also 2 equal angles. Equilateral has 3 equal sides and 3 equal angles. And a scaling, no 2 sides are equal, no 2 angles are equal in measure. Identify each triangle first as based on the sides, scaling, isosceles, or equilateral, and then based on the angles, acute, obtuse, or right. So the first one we see there, number 16, notice the little tick marks here. That tells us that those 2 sides have the same measure. So that we know that that's going to be an isosceles, 2 sides with the same length, and it's an obtuse triangle because we notice this angle here is more than 90 degrees. Number 17 is also isosceles, but this time it's an acute triangle. All the angles are less than 90 degrees. 18, we see a right angle. So that's going to be, and it's going to be a scaling because none of the sides are the same length. Number 19 is going to be acute and scaling. And then number 20 is equilateral, and it's going to be acute. Similar figures have, 2 figures are similar if their corresponding angles have the same measure and the lengths of their corresponding sides are in proportion. So let's use an example to demonstrate similar triangles. Monique wants to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines when her shadow is 9 feet, the shadow of the tree is 45 feet long. How tall is the tree? So here's a picture. Here's Monique. So Monique is 6 feet and she casts a 9-foot shadow. The tree we're going to call X, and it has a shadow have 45 feet, 5 feet, and that's what we want to solve for. So we're going to set up this as a proportion. So the height of the tree to the height of Monique, X is to 6, as equal to the length of the tree shadow to the length of Monique's shadow, which is going to be 9 to 45, or 45 to 9 rather. And so we're going to go ahead and set this up in a proportion. We're going to cross multiply, 9x equals 270, divide both sides by 9, and so therefore the tree is 30 feet tall. Congruent figures, if the corresponding sides have the same length, then the figures are called congruent, and their corresponding angles are also have the same measure. So congruent figures are a subset of similar figures. Quadrilaterals are 4-sided polygons, and we know the sum of their interior angles is 360 degrees, and they're classified according to their characteristics. We have a trapezoid, which has 2 bases that are parallel. We have a parallelogram, which has 2 sets of parallel sides. A rhombus, which is like a square but has all the sides are the same length and they're two parallel sides, but we don't have right angles in the corners. A rectangle has both pairs of opposite sides are parallel, and we also have right angles. And the square is like the rhombus, but now we've got right angles. All four sides are the same, and we have right angles in each of the corners. Classify each of the quadrilaterals, or identify them. So number 23 is a trapezoid. Number 24, we know, of course, is a rectangle. Number 25 is a square. All the sides are equal and they're right angles. Number 26 is a parallelogram. 27 is the rhombus. And then 28, it's a little hard to tell here, but this side and this side are parallel, and that's a trapezoid. Trapezoid ABCD is shown below. We want to find the measure of the interior angle X and then the measure of the exterior angle Y. And they've given us two right angles in this trapezoid and also the measure of angle A. So we can use some information here. We know that the sum of the angles in a quadrilateral has to be 360 degrees. So we have two right angles here. We know those measures, and we know the measure of this one. This is the one we're trying to find. So if I substitute in the measures of the angles I know, and then here's what I'm going to solve for, simplify on the left side, then subtract the 310, and we get the measure of angle X must be 50 degrees. Now, how do I find the measure of angle Y? There's actually two ways to find it. One thing I know is that these two angles form a straight angle, so they add up to 180 degrees, and I can find the measure of angle Y is 130. If you also remember the transversals we talked about in the last section, these are going to be interior alternate angles, and this angle here of A and Y, they have the same measure, which would be 130 degrees. So there's another way that you can do that angle.